Hello, everybody. My name is Eden at the Great Valley Museum located at the Modesto Junior College. Welcome to Astronomy with Fred. Fred, I was looking up at the night sky and I've noticed some stars, planets, fuzzy patches, and a band of clouds. What are the band of clouds and the fuzzy patches? How far away are they from us?
Ian, that is amazing. That's awesome that you notice those things in the night sky. A lot of people, when they look up in the night sky, they really don't see anything but maybe little points of light here and there. Uh, I think the fuzzy or cotton ball type blurry images you see in the night sky, little pockets could be like nebulas. The band of clouds, cloud looking like band that stretches across the sky, you could be referring or looking at our galaxy, the edge part of the galaxy that we call the Milky Way. If you'd like, I could show you a model that I made myself, uh, kind of modeling what the Milky Way looks like, our cosmic address, basically. If you like, we can trade places. Here's my model that I made of the Milky Way Galaxy. If you take a look at this in closer detail, you'll notice there are arms that spiral to a center. We're considered to be a spiral galaxy, a barred spiral galaxy. This is like the bar of it. Made of four main arms. We have the Perseus, Norma, Centaurus, Sagittarius, and over here another smaller arm, which is called the Orion Spur. And we're located right here. This is where our solar system here. You can see it light up here in a second, but we are right there. The actual dimension of that we think so far, the how wide this galaxy is about 100,000 to 200,000 light years apart. The scientists can't agree on that, but they think it's a lot bigger than what we thought. The actual thickness of this, like if you were to look at from the edge, it's approximately 2,000 light years thick. As you know, the Earth rotates from day to day. Also, as you know, the Earth actually orbits the Sun. Now, just to give you an idea of the galaxy right here with our Sun right here is in constant motion, rotating around the galactic center. I use this laser here to kind of show the rotation. Now, if you were to clock the time of how long it takes the Sun to make a complete rotation, it would probably be close to 230 million years to make one complete revolution around the galactic center. That just gives you an idea how enormous our Milky Way galaxy is. Here's another example of how big our galaxy is. Take this light, for example. This light traveling at about 186,000 miles per second would probably take between 100 to 200,000 light years just to go from one end to the other. Now, just to give you an idea how fast light travels, take a look at this. Here's our planet, the Earth. And if you were to clock this, you would notice that light can travel around the globe, around our Earth, 7.5 times in 1 second. That's an amazing speed. Compare that to taking your typical commercial airline. If you were to travel around the Earth in an airplane, it'd take you, just for one spin around the globe, 50 hours, compared to the light speed of 7.5 times in 1 second. It's truly amazing.
Wow, I didn't realize how big our galaxy was. Does that mean our solar system is tiny?
On here, on this particular model, it does look very tiny, very small, but in real life, it's actually very large. I have another model I'd like to show you that will illustrate how big our solar system is. Eden, I made this football field model to kind of show you the distance and how big our solar system is, starting with the sun here in the end zone. And then you have Mercury at the third yard line, We have Venus at the 5th yard line, Earth, our planet, at the 10-yard line, Mars at about the 15-yard line, the asteroid belt between the two planets here, between the 20 and 40-yard line, Jupiter, our largest planet in the solar system, at a 52-yard line, and there's a quite little space here before you see Saturn. Saturn about 5 yards from the end zone on this side. Now, Uranus would take another football field length, and Neptune would be actually three football fields from the sun to where it's at. And then Pluto, the dwarf planet, if we still want to include Pluto in the picture, it would be about 4 football field lengths before you would see Jupiter. Just gives you an idea of the distance between our planets in the solar system. As I mentioned, these planets are not to scale. If this were the sun and this was Jupiter, Jupiter would be way too big. This would not be the right size proportion, but it'd be more like this size right here, this little bead here. This would be a lot closer to scale. You could fit like 12 of these across the equator of the sun. That would be more in proportion, more to scale.
Thank you, Fred, for that great information. So, what you are saying is the band of clouds is the edge of the galaxy. Now, how about the fuzzy patches? You said that it could be nebulas. What are nebulas?
Technically, it's a giant cloud of gas and dust, and usually it's a place where stars are born and also a gravesite. So, a stellar nursery, a gravesite, remnants from a supernova.
Thank you for joining me today for Astronomy with Fred. But wait, stick around for the bonus activity.
Today's bonus activity will be an art project creating a nebula, or what they call a stellar nursery. All right, the materials you need for the art project will be the water, acrylic paint, some mixing cups, a straw, a wide brush, a stipple brush, and a fine line paintbrush, something to put your paints on, a core board, 10 by 10, hair dryer, and safety glasses. All right, take your paint and just put a little bit of paint like this in there, and then put your water. It's usually the recipe is like 2/3 paint and 1/3 water. Take your spoon, mix it really good, and as you're doing this, you'll notice that the water is actually making it blend the paint, the pigment better. And as you're doing it, you take the paint and just kind of see how runny it is. You want it nice and fluid, still a little chunky, so you keep mixing this until it's mixed evenly. This part you have to use some patience. Once again, test it with the spoon, see if it's runny. It's not runny enough, it's almost there. And you can add more water if it's not runny enough. Let's see how it looks now. Oh, it's getting a little better. You want to see a constant stream. You can add a little bit more water. Take a look. Up. It's getting to the consistency you need. And you can really tell now this. Oh, there we go. Did you see that? It had a nice stream there. There we go. That's how you want it. And that will make your paint flow the way you want. Okay, this project we're gonna have Eden join us. And Eden, so why don't you come on over here, show you how to make a nifty nebula. You'll need to first paint your background with black paint, then put a few stars in the background. Next, using a brush, using white paint. When the stars and the black is done, then you can start making your nebula of gases and dust. You can start with the dark colors and then end up with the really bright colors at the end to highlight it. While you're pushing the paint around, use a straw. You just basically put this to your mouth and blow and push the paint around And you can use the hair dryer, that also help. And that's how you put together your own nebula. Okay, so when you're done with your nebula, you need to name it. It's very important to name it. Mine right here, I named the Seahorse Nebula. You can see the front part here where the eye is, the mouth part, the crown up here comes down to here, the tail. So I call it the Seahorse Nebula. What's yours over here?
Well, I named mine the mermaid. If you can see, this is her tail. This is the rest of her body, her legs, where her scales are. That's where you get all these colorful colors. And this is her head up here. So you got the little tail underwater.
How cool. So it's very simple. I I think you should try this. I think it's one of those activities that you can't go wrong with. Bye bye.